Hello.
Yes, sir. Yes,
Ha,
sir.
Good morning
Good
to
morning, sir.
all. Yeah.
Yes, yes.
Last time, maybe weeks back, we discuss about instrumentation of how critical for boiler last week, I think. Further part, just I want to highlight what are the different loops and how in industry total loops looks like and how it is atomized by any other DCS or of any make. So some part will get to know, and some part you will have added value in this session. So today's session is application of steam generation means boiler. So in this slide, how new technology helps like a field bus and all that will be highlighted now. See here in this picture, you can see the burner, top drum, bottom drum, and chimney. Chimney means exhaust. This is what we call as a chimney. You can see in the chemical or refineries or any power plant this type of a tower type, and then gases or smoke comes out. So that is the chimney part. So steam in the steam generation plant, when we use new technology like a field bus, wireless technology, how it will be operated, so that we are discussing. So steam control is here, the final steam is coming out. In this section combustion control part comes. Then third important control is feed water flow. So last time we see feed water and drum level control. So this is the drum, the level of the water inside is a very very crucial control here. So steam control, combustion control, feed water control, and drum level control, and finally temperature control, superheated means this temperature control using the fuel here for the burner, alarms and shutdowns. So all these factors you can see uh, is part of automation professionals rule. So if you see in this slide, alarm, shutdown process, startup, shutdown, temperature control of the heat and burner, uh, or superheated steams, drum level control. These are the, you can see drum. This is the drum, top drum, feed water flow, combustion control, and steam control. So if you see the control strategy here for steam master steam control, you have here first is a pressure transmitter, then flow transmitter here, then the temperature at this point, economizer point. So at finally steam control, you need these important measurements: temperature transmitter, flow indicators, come transmitter, and PI, pressure transmitter. And then you can see here the control philosophy used here. Just I'm complete the slide. You see here how it is cascaded together. So you see here in this slide, uh, this way it is final steam is controlled, steam flow is controlled. You see here three parameter: temperature is also there, flow is there, and pressure is there. And then you have control, further control on the means, because the load of the steam goes, if some plant uses more steam than the generation, then plant trips. Normally in the power plant happens. So to avoid that, this type of very sophisticated cascaded control strategy implemented. In the combustion control, these are the use controls. I'm going further here. You see here combustion control first. So in the combustion control, you can see here fluid here. Then you can have air, which is required for this. So your force FD fans and all. So flow of this air, flow transmitter is here, two flow transmitters are this, and the air is coming inside and it is coming to the for combustion. So air control is this part. You see the this is summarize. So this way it is a, you can see it is a link. And steam is also related control. This parameter is going for the air also. Air control means combustion control. Fuel control loop, oil or gas, whatever you are using, it is coming in. FIC, flow indicating control. Oil or gas. Nowadays, gas we use for combustion. So oil in, oil out, and this oil goes to the combustion here, from here. So overall, you see everything is linked. Steam output, combustion, and uh, feed water flow. So that is what it is called a three element control. So this is the one element, this is the second here, and the third is here. One more is there, a drum level control is here. I will show you here. Fuel control is done here. So overall, you can see here, uh, you need DCS for this, and if you are using field bus devices, there field bus instrumentation or field bus devices, there you need very little wiring, and you can see here everything is on bus. Bus means digital bus. This is a network, and on this network these devices are there. Earlier you have seen each transmitter is looped through the JB and all the wires coming to the marshalling cabinet of the DCS. So that these are the analog signal. However, in the field bus we use a digital signal. You can see in this slide also. So all these transmitter are field bus. So what is happening? They are directly connected to your DCS network. So that is what it is shown here. You have a DCS here, a DCS hardware, and these are the buses here. Oh, this way, combustion control side, all transmitters on this bus, and this is processed to the DCS. Means then you can have other areas like you can see here, feed water flow control. So when you go for feed water here, in that drum level control is linked to that. So drum level, this we have discussed last time. So we are going fast. Few slides I am using out of this. How feed water flow or feed water is controlled in this slide. You can see this is a drum level. This is a fuel. This is a level transmitter for drum level, pressure transmitter, flow transmitter, and this is the steam coming out. So you see here, here you have PID loop. A lot of algorithm is mixed with characterization, arithmetic, summation, integration. Everything is there in this. So you see here how it is linked to this. So steam output set point goes to this PID, as well as the drum level input also goes to the PID, and finally this wall is getting operated. Drum is level is control here. Analog output to the control wall here. So this way cascading is required also, because as I told, boiler is a utility, and any load change, output load change affects, as well as whatever required parameter like a feed water, combustion control, fuel control, it is a must, and it is a cascaded. Mm. So you can see drum level control here. This is a deaerator, and this is the drum here. Hello. So if you see here, combustion control, similarly for second network is for your, say for example, drum level control. Then third will be the maybe your temperature control. So for temperature control, these are the parameters here. Temperature of the steam here, this, and you can see here how temperature is controlled here. Various points are there. So in the temperature control, you can see here the device is incorporated like this. So my point is that, so all these temperature control, again the devices will be loop here on one network. This is third network for the your temperature control. Then you can see here alarms and triggers. So in the combustion control, high steam pressure alarm, high percentage oxygen alarm, low flow fuel alarm, open air flow, low air flow. So these are the tripping or alarm to be configured for combustion control. Similarly, for feed water, alarms and triggers are high level alarm, low level drum level, high level drum trigger. Means it is above the alarm. If your alarm is not acknowledged, or you have not taken action, then it goes to the trigger tripping point. Low level tripping and open drum feed water. These are the alarms for feed water. Then in the water drum, so these alarm also separately configured in the these systems, DCS systems. So you can see here graphical screens for operators. Operator graphics for the boiler looks like this way. This is the chimney part. This is the boiler part, and these are other areas: steam, fuel, and this is the trend display. Critical loop control trend. This is a combustion control area. So this is the one controller, second controller, third controller, and you can see there are graphics here, process value, set value, output here, and you can have auto, manual, and you can adjust. See, set point is 100, PV is 100. This is for indication purpose shown, but this is the what, one faceplate of one controller. Similarly, in one screen, you can configure eight maximum, or depend on the resolutions of the uh, screen. So, but eight is a standard. Eight, uh, this faceplates you can configure, which are critical for that particular section, combustion control. So you see here this way it is shown. So colors are also identified. So set point means this color. So you can see this is a set value. PV means this color, yellow. So you can have PL, and this is output. So this is way. So same way. So our operator can understand. Then for acknowledgement of the alarms and all, it is the, you can see this alarm pay. This is one your tab. Similarly, there is another bottom tab where you can see the alarms also. This is the trend display. You can see for this particular section, you can see the previous last 8 hours how this parameter was operating for your analysis or diagnostics. So that way you can see the trend of this or trend of this here also. And this is a you can have a multiple trend also. You can have a different colors for this one para one your process control loop. You can have this second this, or you can have let's say parameter, particular parameter. You can have different trends how it is behaving for analysis purpose. So this way it looks like this is a picture where I told chimney means this part. This is the chimney. These are the chimney means exhaust. So this is what a boiler overall looks like. I will give you some brief about the boiler basics now. Just a minute. So you can see the picture or actual picture of the boiler here. One, two, three boilers. This is the RCF boilers I'm talking. So again, just for refreshing, boiler is a closed pressure vessel with a capacity exceeding 25 liters, used for generating steam under pressure. It includes all mounting fitted to such vessels which remain wholly or partly under pressure when steam is shut off. So industrial boilers, steam generators, closed vessels made of steel and used for generation of steam. And here combustion of a fuel is either coal, coke, oil, wood, saw, dust, biogas. Steam is used for producing power for industrial process work. So steam is very important for, and it is used for heating purpose in the chemical processes. Like in RCF, we use for uh, manufacturing of nitric acid, manufacturing of methanol, manufacturing of urea. Everywhere steam we use. Requirement of perfect steam boilers. So it should be absolutely reliable, capable of producing maximum steam at required pressure for a minimum of fuel consumption. So this is what we call as a optimization. So with a minimum attention and a minimum initial cost and operating cost. So this way, this is entirely you can see ideal parameters. It has to be simple construction, quick starting from cold means startup has to be simple, strong enough against temperature, stress and strains means your construction has to be very rugged, well designed combustion chambers, less floor area, space and lightweight. So these are some requirements of the we can say for manufacturing of steam. There are classification vertical, horizontal, or internally fired or externally fired, fire tube. So you can see here water is outside the tubes while the hot gases are inside the tubes. So there are various types of this, and in our case we use water tube boilers. Means water is inside the tube. See, water tube contain a large number of small tubes through which the water circulates, and the fire and hot gases being outside the tubes. So Babcock and Wilcox, Sterling, these types of boilers are water tube boilers. These are the manufacturer Babcock and Wilcox. Nowadays, Thermax also is a very good. Thermax manufactures the boilers. Mm. So, as I told, water tube boilers. So boilers, natural circulation is accomplished due to the density difference between steam and water. So water is circulated in the tube by steam your density parameters. And you see here what is the critical pressure? Critical pressure is 225 atmospheric, and saturated temperature is 370 degrees of a steam. Uh, what are the advantage of high pressure boilers? Chances of scale formation in tube walls are low due to high velocity of feed water. Quick startup from cold is possible. Increase efficiency. Fit for meeting variable load quickly. So I'm skipping some slides which are not relevant today. These are some mechanical point of view. Hmm. So in our case, the boiler type is tangentially fired, radiant, outdoor, by drum, non-reheat type industrial boiler, and it is a suitable type for firing with either oil or gas. These are our boilers, as I told. Three boilers we have, and this is the chimney part. So this is the boiler. Boiler one means one boiler graphical overview. So where in the overview you can see here this part, you can see these are the burners here tangentially fired. One, two, three. One, two means two floors. So you can see diagonally burners are there. These are the burners. You can see on floors. Then you can see here the tubes here where water is there, which is getting heated, and this is the water two drums here. So feed water coming to for the boiler, and you see these are the walls for burners to start the burners. Fuel control. So various elevations are mentioned here. First floor, second floor, like that. And this is the what graphical trend here, graphical view. So n- new steam generation means this is a boiler actually, steam generation plant, which is having capacity as I told 170 tons per hour, tangentially fired, radiant, outdoor. This I have mentioned. So this is the what capacity, mechanical capacity. So in the our boiler, you can see these are the interlocks for safe operation. Very low airflow, less than 30%. That is this. Very low feed tank level. Furnace pressure very high. Low instrument air pressure. Failure of both FD fans. Failure of ID fan, induced draft, and scanner failure. So you can say these are very very important interlocks. Each has interlocks uh, for safe operation. In the boiler, we have seen combustion control, drum level control, and superheat steam control, superheat steam temperature control. There are losses in the boiler. You can say heat loss due to the unburnt carbon, heat loss due to the dry flue gases, heat loss due to the moisture in the fuel, and heat loss due to the surface radiation. So why interlocks are there? Because these are the losses we have to avoid. Planning and managing the boiler maintenance. in the context of increasing productivity and quality, operational maintenance strategy play a vital role. With efficient maintenance management ensures a good economical operating conditions. So poor maintenance results in economic losses, increase in downtime, deterioration of life cycle of the equipment and times, failure of the equipment beyond repair. So the boiler maintenance, as far as the electrical instrumentation or electrical or civil point of view, civil department's point of view, is very crucial here. So you can see here, good maintenance is a tool for efficient energy management. If you are maintaining properly, it is efficient. Means energy you can save, and that is directly converted to their business profit margin. So for proper maintenance, regularly you have to inspect the critical parts. So health of the equipments are to be monitored by the operators on hourly basis from operation point of view and for better reliability of the equipment. So inspection, physical inspection is required here. So the operating staff, operators in the plants are different. They are allocated different areas, and they record the inspect and record the readings of that either vibration, pressure, temperature, flow in their logbooks. Every day, a maintenance group should check the health of the equipment, including its lubricants and maintenance angle. Every day, maintenance team, mechanical, electrical, instrumentation goes take a round and check physically check the health of this equipment. So boiler tube failures, you can see here this picture. These are the boiler tubes which get damaged here. You see here this picture for demonstration is used, how get damaged. This is the inside view of when it was taken to the maintenance. You can see these are the boiler tubes here. You can see the boiler tubes here inside the this boiler work is going on. Now steam drum inside view. You can see drum looks like this way. I'm talking fan vane controller view. Fan, ID fan, every fan we are talking. This is the fan which is this covered with net to avoid safety. And this is a duct to which air goes inside and goes out. So as per our in our factory we have these three boilers: boiler one, boiler two, and boiler three, and this is a common chimney. Chimney. So duct through duct it is connected, and the smoke and all goes out here. Then we have a boiler and a turbine generation control room is together. There are various department for this mechanical workshop, electrical department, or instrument department, operating staff in the control room. And then if you see here, water is very important because feed water has to be conditioned, means with silica and deaerated water is required. So you can see cooling tower, water treatment plant uh, is also, these are the utilities for the boiler, we can say. This is what the layout of the plant. So this is about the total look of the industrial boilers requirements. Uh, so I think now I will give you look of the, just minute. This I'm closing this. Okay. So this. Mm. So this we have discussed boiler burner management, and as I shown the burners in the boiler. See burner alarms, which burner is running, entire indications are shown here on the through scanner also. You can see here burner management on DCS screen. Similarly, we have actually wired indicators, means that is called auxiliary panel also. We are not dependent on only DCS. There is a parallelly we have auxiliary panel like this. I will show you here. This is auxiliary console. This one is called auxiliary console, where you have physically wires and indicators, push buttons, and alarm annunciators are there. However, in the DCS also we can see this burners. So you can see here this MTV wall open, close, igniters, permissibles. So you will come to know how which burner is on here, and we if you want to stop this is related to flame is on, permissive and permissive, this is what uh, third is I told solotron is there for boiler auxiliary drum level monitoring, this separate equipment that time I just huh. So this is the boiler auxiliary control. Auxiliary means if the DCS fails, through this panel, it is started, stop, control, safe shutdown. So your solotrons are here. You can see here, and these are the push button indicators for the burners, and these are the critical alarms for drum level, combustion control, feed water. That, and I told you these are the two buttons for emergency start and stop. These two buttons, emergency tripping of the boiler. This is the conventional system still we are using as a backup in case the DCS fails. So this we have discussed. So why drum level control? Objective is to avoid shrinking and swelling effect in the drum level. And this is three element control. Uh, Day before I also two out of three logic because level control is a very important. Here you can have a solotron use here. So this is the steam drum. This is the solotron drum level sensors conductive type, and that goes means this input indicated in the control room. Drum level transmitter here. There are two out of three, so this is one transmitter which is showing 62% presently. This is the what transmitter is one transmitter with you can see how it is installed HP, LP, and tappings, isolation walls. That is the manifold here. This is the three-way manifold here. Here this is the three-way manifold here. So whenever for maintenance you have to isolate wall from here, calibration testing purpose here, because you can see you can close this wall so the line stops here. These are all because of high temperature it is insulated, this one. This is old wall, so it is covered. The display is here is 62.6, and on the graphics whatever transmitter is showing on the uh, field side, but on the graphics you can see the level here, steam drum. This is a steam drum, and this way you can see the level here by using this transmitter. This one is also there. In the drum level, you have JB junction box. You can see the cables here, individual cables because it's a hard analog signal. So boiler feed water section, you can see water is deaerated. Water is pumped in the boiler feed water pump at a pressure of 145 kg. Capacity of boiler feed water is 85 tons. So the level of the feed water tank has maintained at 40%, and level control loop for this feed water tank, uh, 2 LIC is the tank 1034. So this I was just repeating because this is what as I when you start your career in industry, you must know where which instrument and how to read that. So we are talking about this loop, boiler feed water control loop, and the tag is 2 LIC. 2 is the number indicates because this is a standard, and LIC is the level indicating control, and 103 is the number. So this is the boiler feed water control loop 2 LIC 1034. So you can see in this field area means from here field starts, and from this side control room area. So in the field side, what you are seeing, process area, process equipments, and junction box comes in the field. Control room you can see analog marshalling cabinet and system cabinets. So two parts: analog marshalling cabinets and then system cabinets. So in the field, we can see in the process area, you can see the transmitter mounted. I have shown the actual transmitter. So the transmitter is here, two wire, and from transmitter you can see plus and minus wires, 420 milliampere signal generator. So this wire, this cable has a number. Then you can have pair and core number and tag number. Here it is mentioned on this cable. You'll find one tag where you it is everything is mentioned, so identification will be easy because when you are here in this junction box, you can see the tags are here, and through that you will come to know of which transmitter cable is this one. So for that purpose, this is the tag here, and then this wire comes to the JB, and in this JB again, JB has a number, and from this JB, one multi-pair cable. You can see this is the multi-pair cable, and cable number, pair, how many pairs, and JB number is mentioned. So this cable is coming from which JB? For example, you can see here individual cables, and this one is a multi-pair cable going from to the this one is a multi-pair cable. You can see here which carries the input and output signal inside the JB towards the control room side, means here. So this cable, multi-pair cable, has we from which JB, how many cores and cable number is mentioned, and this goes to the control room marshalling cabinet. So then you will identify through the drawing this particular JB carries this transmitter and which number. Accordingly you can wire inside the marshalling cabinet. So in the marshalling cabinet, when this cable comes, again the cable number, and when it is routed in the terminal box, maybe here some intrinsic say barriers or some converters are there, and through that then this signal these wires are further connected to the respective input cards and output cards in the system cabinet. So in the system cabinet you can see these IOs, input and output, and controllers also there. Then uh, same is the output generated by this loop, PID loop, routed back to through the marshalling cabinet. This is the what marshalling cabinet here, and through this again this another cable, output cable, goes to the JB, maybe same cable number, because in the input output cable goes on the same multi-pair cable, and here the number will be the same then. And then this wire goes to the respective IP means in uh, current to pneumatic converter, and then it goes to the control wall. So this is the what the one loop uh, wiring is done in the plant. This is one of the loop it is shown to you. And whatever I have shown you, you can see here, 2 LIC 103. So this transmitter is installed for level measurement of this tank, feed water tank. So these transmitters, you can see here, here this transmitter. Okay. Then the JB we are talking here is this JB junction box here. Then when we are talking about a marshalling cabinet, means wiring and all control room. This is a control room. So this is a marshalling cabinet. You see the terminals wires are separated here with proper tagging, and then with some signal conditioning yellow board, some conversion is required, signal isolation is required, and then these wire signals are coming to the IO cards. These are the, you can see these are the racks in different racks. Based on the plant capacity, you have to this input cards, output card, input card, output card. This one, and there you can see the tag which mentions the this input card is taking inputs from which cable, and this cable goes where. So this way we identify for maintenance purpose when we are replacing the card or replacing any hardware here, failure of hardware or replacing of the transmitter. So this drawing is very important. And then the controllers, power supply controller, network interface cards are here in the system. So when we see the in this slide, uh, this part, L, marshalling cabinet and all is here up to here. This, and further the signal goes to the input output signal conditioning means this, and control is shown here. You see here this FCS is mentioned, network interface unit, slot, channel number, and finally node. So you can see here when this signal wires are coming here, this way it in the, on this it is mentioned which node and all. So this is the what one node, second node, third node, and there inside each node you can see the slots are there, 8 slots are there, and each slot there is a one card, and there are standard card, power supply, communication interface card this side. Sorry. So this way the hardware is there, and then finally all this network node signals, input signals are coming here to the controller. The controller is here. So again in the controller, power supply redundant card, communication interface redundant card, controller redundant card is here. So like this, in the DCS hardware. This is a Yokogawa DCS, so names are different. FFCS is the name for this, like, and finally, then signal goes to through control net. VNet IP is their communication protocol or dual redundant communication protocol for control network, and on this their stations are there. These are their graphical user workstations are there. These stations where you can see this integrated membrane keyboards, touch screen. Now the screens are coming with high density, ultra high density, bigger screens. So and with a specialized uh, console hardware, which will take care of the ergonomic requirement because it is a continuously you are there for 8 hours, you are sitting, and they are taking care of your mm, illuminations from different from these screens that damages the means your the health issues should not come. So the nowadays designs are coming with the ergonomic factors considered in the display as well as your sitting arrangement convenience. So this is the graphics you can see on the workstations of this particular section. Now I am showing you this I2P converter is this, and this is the control wall which is shown in here. So this I2P and this control wall picture is here. You can see here. This is a control wall. And this is I2P. So this is the what the boiler has. So I'm coming to the end almost. Safety valves for steam drum pressure. Two safety valves are installed on steam drum, left side and the right side. They are very important. Safety interlocks for boiler. Boiler will trip with the following condition occurs: airflow less than 30%, failure of both the FD fans, drum level less than minus 170 millimeters, furnace pressure high, emergency trip push button. That trip button I have shown is somebody has by mistake press one, no, boiler will not trip, but two out of two, both the if it is trip, boiler will trip. Total flame out when flame is sensed by the scanner means if
Hello.
hello
Hello.
hello and instrument air pressure less than 3.0 pg. So this is the what tripping
Hello.
condition. Ha, hello
You are not audible. Hello.
hello.
Yes, sir. I'm audible. Yes,
Yeah,
hi.
I listen you,
You are
but
not
you are
audible. Ah, yes, sir.
hello
Yes, sir.
audible. Ha- Hello now it,
Ah,
it is
yes, sir.
audible na. Hmm.
Ah,
So this
yes, sir.
is
You are
the
audible.
this is what related to the boiler, and I think this is the one area expertise is required, and in the boiler operations as it is coming under act, so regulatory compliance is there. So specialized boiler operator engineers and boiler operator certified operators are required, and that there every 3 years they have to pass the test which for this. So for operation point of view, uh, this is the what compliance that the operating people means I'm talking about operators. Hello, chemical engineers
Okay,
and
sir. Very nice.
hello.
Really very nice session going on. Yes, am I audible?
Yeah, I'm yes, I'm listening, madam.
Yes, sir. It is very nice session on boiler and compressor water you have taken for the B instrumentation. So they really get the benefit while doing the work in the companies.
Yeah,
Okay,
yeah,
so I think today we have finished our BE sessions. In the afternoon,
yeah.
we will meet for SE and TE session at 2:50 p.m. and
Okay.
4 p.m. Yes, sir.
Right, right. Okay, okay. Thank you.
Yes, sir.
Thank
Okay,
you.
sir. Okay, sir. Thank
Thank
you.
you for patiently listening. Thank you.